To find the confidence interval, you need to use the formula x bar minus the margin of error is less than mu is less than x bar plus the margin of error. And the formula for margin of error is this formula here, z sub alpha over 2 times sigma over the square root of n. In this video, we're going to be using a calculator, but if you want to do it by hand, these are the formulas you need to use to find the confidence interval. So a simple random sample of 125 SAT scores has a mean of 1,522. We will assume that SAT scores have a standard deviation of 333. We are going to construct a 95% confidence interval to estimate the mean SAT score. Well, we need to pick up what we are given in the question here if we're going to find the confidence interval. The first thing we have is our population standard deviation, because it says we assume SAT scores have a standard deviation of 333. So that means sigma is 333. Then we have to find our mean, our x bar, and that is 1,522. And we need to know how many SAT scores we're looking at. What is the sample space? And that is 125 scores. Finally, we need to find the confidence level, the C level. And for this one, it is 95%, so 0.95. Now that we have everything, we're going to put it all into our calculator to find the confidence interval. So bring up our calculator, and we're going to go to Stat, over to Tests, and since we know what sigma is and we're trying to find an interval, we're going to do number 7, Z interval, because we know what sigma is. So go in here, and we want to do statistics, not data. And then we're just going to put in our information. So sigma here is 333. Our x bar is 1522. N is 125. And our confidence level is 0.95, so just leave it as is. Hit enter. And here we get our confidence interval to 1 decimal, and I'll just leave it as 1 decimal. So we're going to have 1463.6 to 1580.4. And so for this one, we are 95% confident that the true mean SAT score is between these two values here. Now, what if we want to be 99% have a 99% confidence interval instead of a 95? Well, everything's going to stay the same. Sigma is still 333. X bar is still 1522. N is still 125, but this time our C level is 0.99. So, going back into our calculator, again, we do stat, test, and Z interval since we know what sigma is. And everything stays the same from before, except this time our C level is going to be 0.99. And we just calculate, and we get this confidence level when we're 99% confident anyway, which is going to be 1445.3 to 1598.7. So we are 99% confident that the true mean is between these two numbers here for this confidence interval. Now, last is, what is the margin of error of each confidence interval? Well, we can use the margin of error formula at the top, or we can just do a kind of a workaround where we only take the highest value from the confidence interval, subtract it from the lowest, and then divide by 2, which is what we're going to do here. But if you want to use a formula, will work just the same. So for the confidence level of 95%, we're going to find the margin of error. So E here is going to be highest minus lowest, so highest is 1580.4 and lowest is 1463.6. So 1580.4 minus 1463.6, and then just divide by 2. just do the arithmetic here, and we're going to end up getting a margin of error of 58.4 for the 95% confidence level. Now, confidence level, that was 99%. And we want its margin of error. So again, highest minus lowest divided by 2. So 1598.7 minus 1445.3 divided by 2. And again, we do the arithmetic here. We're going to get a 76.7 margin of error. So the difference between the two confidence intervals is not much, but when you're doing two different percent levels, 95% and 99%, there will be some difference. Not a whole lot, but it's still a difference. And for the confidence level margin of error, all you do again is you can use the formula up top, or you can just do the highest minus the lowest divided by 2 as another way to get the margin of error.